The insulation resistance of 1 kilometer of cable having a conductor diameter of 2 cm and an insulation thickness of 2 cm is 500 mega ohms. If the thickness of the insulation is increased to 3 cm, find the new insulation resistance of the cable. First things first, we have to write our given. Okay? We have to get used in writing our given first so that there will be no confusion. Okay? So we have the givens. Our given is the length, which is 1 kilometer, also equivalent to 1,000 meter. We also have the diameter, which is 2 centimeter, and if the diameter is 2 centimeter, our radius is 1 centimeter. Also, we are given insulation thickness of 2 centimeter. Also, we are also given the resistance, which is equivalent to 500 mega ohms. If we say mega, it is raised to negatives. It is raised to 6, right? If it's mega, then it's raised to 6. Also, it is said here in the second part that the thickness of insulation was increased. So, in the second part, this will be our first part, and in the second part, the insulation thickness becomes 3. Okay? So, let's go ahead and plug. We are asked to find here the new insulation resistance. We are asked to find the new insulation resistance. New insulation resistance. We have R is equals to phi rho pala, rho 2 pi L ln R2 all over R1, wherein our R1 is the radius of conductor, and R2 is radius of insulator. Our R1 here is equivalent to 1 centimeter and our R2 is equivalent to 1 centimeter plus the insulation thickness 2 centimeter is equals to 3 centimeter, right? Okay, so let's plug in. We have our R, which is 500, right? 500 times 10 raised to 6 ohms, which is equivalent to the rho, which is the missing part, all over 2 pi, multiply the length of 1000, we will obtain the value of our rho, which is equals to 100 times 10 raised to 6 plus 2x all over 2 pi 1000. So it is equivalent to the calculator takes so long to do the task. So basically we just cross multiply this one. This will be over 1. So the answer will be 500 times 10 raised to 6 multiplied by 2 pi times 100. So my calculator is taking so long. So let's retry again. We have times 2 pi times 1000. 1,000. 1,000 So we have 1,000 times 10 raised to 6 multiplied by 2 pi times 100. So my calculator is taking so long. So let's retry again. We have times 2 pi times 1,000. So we have 1,000 times 10 raised to 6 multiplied by 2 pi times 100. So we have We seem to forget something. We have we have ln 3 over, because this one is R2, all over 1, right? So, sorry, we have to do it again. Times 10 raised to 6 is equals to x all over 2 pi 1000 multiplied by ln 3. We have the value of, if solve, we have the value of our row, which is 2.8596 by 10 raised to 12, which is, when simplified, we have 2.86 times 10 raised to 12. So we will use that to find the R of the second part. We also have our R1 as 1, and our R2 will be, it says here that increases at 3, so we will have 3 plus 1. Okay, so R is equals to phi all of rho 2 pi L multiplied by ln of 4 over 1. Okay, so R is equivalent to 2.86 times 10 raised to 12 all over 2 pi multiplied by 1000 ln 4. Simply 4. This one is simply 4. Okay, so we will calculate it. We will have the value of 6316816.4, or approximately 6314816, or 631 mega ohm. That would be the values. This could be an answer, this could be an answer, this could be an answer as well. So it will only depend in your choices or in what is said in our problem. Okay? So thank you for watching.